All right, so in this video, we are going to look at using the law of sines. So let's check that out. Oops. Keep doing that, sorry. All right, so here is our law of sines. So first off, the law of sines is actually a lot of equations in one that's talking about using ratios. So essentially it says that, and this is not right triangles, this is any triangles, it's not specific. So it says that the sine of an angle over its length, so the opposite of that angle, will always be in ratio to the sine of b over b. So the sine of a is to a as the sine of b is to b, but also as the sine of c is to c. So and notice that these are ratios, so you could also write them as, for example, b is to the sine of b as c is to the sine of c. So you can set up all of these equations, and all you need in order to do it is a pair. So if you have a pair, so in other words, if you have an angle and a side across from it, then you are able to use the law of sines. So let's look at an example of that. So the first one says, given this triangle, find the length of x using the law of sines. So we're going to look at it and say, okay, do we have a pair? And we do. We have this side and his angle. So that tells me that the sine of 18 degrees is to the number 16 as, now the only thing you have to be sure of when you set these up, I love ratios because there's just so many ways to do them, but you just need to make sure that you either have the signs together in denominators or the signs together in numerators, okay? As long as you have that, then you're good to go. So we're going to have sine of 51 degrees divided by x. Okay, notice this triangle is not drawn to scale whatsoever. It's just kind of thrown at you. But we just set it up. The sine of the angle is to its opposite side, as the sine of any other angle is to his opposite side. So now if we cross multiply here, and then solve for x, you will see that this will happen. So if you cross multiply, you'll get x times the sine of 18 degrees is equal to 16 times the sine of 51 degrees. And then you would just divide both sides by the sine of 18 degrees. And you would get that x is approximately, I am going to put this in my calculator right now, off screen here. Again, just depending on your calculator, you'll put this in different ways. I always like to start with the trig function in the numerator. So in my calculator, I push sine and then 51. And make sure that you are in degrees. And I am, yay, okay. So sine of 51 and then times 16 equals, and then divided by, I always like to use parentheses, so divided by parentheses, sine 18. And I get that this is approximately 40 point, it says 4 decimals, so 238, there's a 35 here. So to 4 decimal places, that if you want to round to the 4th one, you only look at the one after him. He's a 5, that's going to move him up. So we're going to go with 2384. So let's put that in. So x is equal to 40.2384. That is the side. It didn't give units, so we don't need to worry about units, but just watch that. If it had been in feet or meters or whatever, make sure you put that in there. All right, so here's another one, but this one, they didn't give me the picture. I have to like draw it myself, which is completely fine. Draw yourself a triangle. And notice, just like in that first one, your triangle does not have to like match anything. Just draw yourself a triangle. So it doesn't have to be to scale, but I don't know, we can kind of try to make it to scale. How about, let's see, we need a 75-degree angle That's just kind of shy of 90, maybe like that. And then we need a 44, which is just shy of halfway. I don't know. So maybe it looks something like that, where this is my 75. This one's 44. I know that's tiny, which means this guy will be angle B, right? So he's A, that was backwards. I made him C, 44 was A. And so remember, across from those are their respective sides. So wherever angle A is, little a is across from him, etc. So we've got our picture labeled. Oh, they told me that B is 17. And now I'm using the law of sines, and I just got done telling you that you need a pair in order to use the law of sines. I don't have a pair right now. I don't have big A, big C, little c, big B, little b. I have no pairs, but this is a triangle. And I know that the sum of the degrees is going to be 180 degrees. So I can just, oops. So I can just subtract off that 75 degrees, which would leave me with 105, and then subtract off that 44, which leaves me with 61 degrees for this one. And then I always just like to check that. 5 and 4 and 1 makes 0, and 7 and 7 is 14 and 4 is 8. Okay, so now I do have a pair, and I can use the law of sines. So you see my pair here is going to be my B's. And so all we need to do is set up our ratio. So we're just going to say sine of 61 degrees is to 17 as, pick one. It really doesn't matter. We have to find them both anyway. So I don't know, let's do sine 75 degrees is to little c. So again, with the cross multiplying and solving, you'll end up that c is approximately, you'll have that 17 times sine of 75. And then you will divide both sides by that sine of 61. So that'll be your C. And then to find A, we can just set up that same ratio again. And just for the heck of it, I'm going to do it this way, just so you can see that it doesn't matter. So in this one, I'm doing that 17 is to the sine of 61 as little a is to the sine of, what was big A, 44? Okay, so notice, as long as you're lining them up correctly, I've got sine in both denominators, and 17 and 61 are an opposite pair. A and 44 are an opposite pair. So as long as you have it set up correctly, you're good to go. Cross multiplying and solving here, we'd get that A is 17 times the sine of 44 degrees over the sine of 61 degrees. And you'll be approximating that. So there's using the law of sines. All right, let's just keep going. All right, let's see. So this one is very similar to the last one. A pair is given straight to you, which is kind of nice. And actually, in this one, we're going to have to find an angle first. When you find the angles, you have to be a little bit careful about ambiguous cases. So the problem with solving for an angle is, well, not necessarily the problem, but inverses will always have, or in, that first, like between 0 and 180 degrees, you'll most likely have two places where sine is a particular value. Not most likely, you will. So what you're going to have to do is just, when you find that first angle using your inverse sine, you need to check the first quadrant possibility and the second quadrant possibility. Let me show you what I mean. So I'm going to draw my triangle. Angle A is a pretty big one. That's 104 degrees. So that's an obtuse angle. And then it tells me across from that is 28. These don't matter as far as order goes, as long as you call this little guy B and this little guy C. So the B is 20 degrees. So it just told me to start with B. It really doesn't matter. But let's set this up. We're going to have sine of 104 degrees divided by 28 is going to be equal to the sine of angle B divided by his side. Oh, well, it does matter. You need the pairs, right? So this is what we have when we cross multiply and solve for the sine B. It's going to look like this. All right, so the way to find this is in your calculator, you're going to have that B is sine inverse of all of that. Let me go ahead and find that piece. That way it looks a little sweeter. Let's see. Again, just make sure your calculator is in degrees when you do this. But we have the 20 times the sine of 104 divided by that 28. So this is approximately 0.693. There's an alarm. What we need to find is sine inverse, right? Because we need to know what is the angle that gives me that value. So now again, recall your calculator is only going to give you the first quadrant possibility. So your calculator is going to give you a number between 0 and 90 here. So if you do your second sine, that's going to give you, so sine inverse of that tells me that angle B is approximately 43 point, does it specify here? Nope, let's just go 9. Okay, that's for angle B. All right, so sine inverse only gives you the first quadrant possibility. Now keep in mind, sine is also positive in the second quadrant. So if we know that in the first quadrant, this is 43.9, if I want to know the second quadrant possibility, you see I've got to move over here, and we know that this is 180. So we can find the second quadrant possibility by doing 180 minus that 43.9. So this is first quadrant. The second quadrant possibility then, so the obtuse angle, and there's nothing wrong with an obtuse angle in general, right, would be 136.1 degrees. All right, so now look back at your triangle, and could either of these work? So remember, the angles have to add up to 180. They can't be more than 180. So if we check 43 with that existing 104, we're good to go. Oh, but wait. If this was my angle and I already have that 104, I'm over 180. So see, that tells me that that second quadrant one is not a possibility. I don't need to worry about it. So now I can just come in and put that 43.9 degrees. I can find angle C by subtracting from 180. And then I can find little c by using the law of sines again. So I'm not going to finish doing that one, but the key here, the thing that you always got to remember when you're solving for that angle is to check first and second quadrant possibilities. Neither of them will work, in which case there's no solution. And actually that'll come up in a different way, which maybe you'll see. But okay, so either exactly one of them will work, or both of them will work, in which case you have two possibilities for your solution, or neither of them will work, and you'll know it's neither because your calculator will just yell at you right off the bat and tell you can't do that. So let's see if that comes up in this second one. I'm not sure if it will, but so anyway, finish this one up with angle B being 43.9. All right, so let's look at this second one and see if we end up with a problem on this one. So this one, they gave me, I'm just going to draw a triangle. Whatever, here's my 50 degrees for angle B. And I know across from him is the little b, and that's 43. And then these others don't matter, just as long as they are matched up. So let's just start by trying to figure out what angle A is. So we'll have sine of 50 degrees with his match. So 50 goes with 43. is to the sine of angle A to little a. Okay. Oh, wait a minute. I forgot to write what little a was. I was like, wait, we can't do it. So we know that little a is 100 here. All right. So then when we cross multiply, we'll have 100 times the sine of 50, and then we will have divided both sides by that 43 to move it over. So that tells me that the sine of A is approximately, so I'm just going to put this in the calculator. So we've got that sine 50. And again, we're in degrees. So we've got that sine 50 times 100, and then we're going to divide that by 43. So this is about 1.78. All right, this is a problem. So look at this and see if you can figure out what's wrong with this. We're asking the sine of an angle. So I want to know the sine of what angle is equal to 1.78. That's our question. So hopefully, do you see the problem? Sine can't be over 1, right? Recall that sine and cosine are always between -1 and 1. If you look at the graph of sine, remember it looks like this. This is 1 and this is -1. You can't possibly get a 1.78. But if you don't notice that and you proceed to your calculator will then yell at you. So if you try to put this inverse sine in your calculator, can't remember what mine will tell me, probably just error. It says calculator error domain. Okay, it will yell at you. It will not let you do it. So that means that there's no triangle here. We can't do this. So in this particular thing, it says put DNE in for all of them. And I just wanted to show you, oh, I got rid of my calculator. Just pull up the calculator app. And again, just so you can kind of see this in action. So on the computer's calculator app, you put in the value first, then come in here and do second sine. And ooh, it just said invalid input. Okay, so you cannot do this. It's no good. So you would just put DNE in for all 3 of these. Ooh, this one wants pretty high decimal. Oh, so in this one, what you're going to have is 2 possibilities. And it actually, I like this question because it kind of really breaks it down for you and says, all right, so here's what's going to happen. And so you can, let's just see this one in action, how that comes up. So we would draw our triangle. This is 36.3 degrees for A. Little a is 186.2. And then these don't really matter, but little b has to be 249.3, and that's little c. So when you try to put this in, so you're going to have sine of 36.3 degrees over 186.2 is equal to the sine of b over 249.3. So what you're going to get in your calculator here, so we're going to do 249.3. Oops, I had already pushed something on accident. 249.3 times the sine of 36.3. And then we would divide that by the 186.2. So we get about 0.79 here. Okay, and actually it says, make sure you round that part of it. You see how this one's kind of giving it to you in pieces. 264 will be 5 decimals. 792636. So 79264. Okay. So when you put this in your calculator, when you say, okay, so angle B is going to be the sine inverse of that big old number. I'm just going to put 0.79 for now. You're going to get, so here, second sine of that answer we just got is 52 point, and now here it says just to do 1 decimal place. This would be 52.4 degrees. Now notice, so this is the first quadrant answer, right? Let's see what the second quadrant answer would be. we would do 180 minus that, right, to get into the second quadrant. And that would be 127.6. So now just ask yourself, are both of these answers okay? Well, the angle that we're given is 36.3 degrees. So if I were to add on 52.4, that's less than 180. So he's good. All right, now let's look at that second one. We have 127.6 degrees. If we tack on that 36.3 that we already know, 7 and 6 is 13, carry the 1. Oh, that one is also less than 180. So he's good as well. So the reason that there's two triangles here, I'm going to try to draw it, is because one of them can have, so this first one has angle B being an acute angle. So it's acute all around. I know that looks like an equilateral, but whereas the second one has angle B being an obtuse angle. So I'm going to try to kind of draw that where you can see this angle's the same, but this one, wow, that was really bad. So the thing is that these angles didn't change and these side lengths didn't change. So it is possible to have triangles that have that same angle, same side length, but then have different shapes other than that. So anyway, so what you'll have to do, this one just says, okay, so pick one of them. And actually it says it wants B1 to be the acute angle. So your B1 would be the 52.4. And the B2 would be your 127.6. And so then it says, now just finish the triangles all the way through. So those are your three ambiguous cases. So this is just like those last ones. You will start by solving for an angle. This one has a picture. It's drawn for you, but it says A and B are separated by a lake. There's the beautiful lake. To find the distance between them, he locates a point C on land so that he has this angle. So the thing is, he can't measure across the lake. Okay, so this is actually something that surveyors do, is they use triangles to find these distances they can't reach exactly, use trig functions. So we're going to find the distance across the lake by using, in this case, law of sines. So notice we do have a pair. We have that 53.4 angle, and then we have that 483 that he was able to measure. And then we know the 374, so you can use that to find angle B, which will give you angle C, which will then give you the distance across the lake. So again, in this one, the first thing you would do is find angle B, and just watch for those ambiguous cases, check first and second quadrant to see what's going on there. So the first thing we could do is find angle B. Second, find C, because now you have two of the angles. And then third is to find length, little c, right? Which is what this actually is. That's little c. This is little b and this is little a. So that's your plan. All right, so I think this one is similar. Communication tower is located at the top of a steep hill as shown. The angle of inclination of the hill is 71 degrees. Now the picture is already given for us, which is nice, but angle of inclination for any kind of mountain, ramp, hill is always from the horizontal up, okay? Actually, angles of depression, horizontal down, angle of elevation, horizontal up. All these angles are always to a horizontal. So just keep that in mind. And so then they're going to attach a guy wire. I always thought that was guide wire, but to the top of the tower and then to the ground. So again, the picture is given to you. It looks very nice. And it says the angle formed by the wire with that hill is 8 degrees. So it wants to know what's the length of the cable. So that dotted length there, what is that going to have to be? So you will be able to work from there to find your different pieces. So that one won't be too bad, I don't think. And you can actually, there's one that's worked out for you already, so you can look through that example as well. But this is just a matter of getting those pictures down. Let's see, here we have a pilot. I don't know, let's look at this one. So it says a pilot is flying over a straight highway. He determines the angles of depression to 2 mileposts. So that's the 33 and the 50 that are given. And again, we could have done that ourselves. But from where he's located, angle of depression, again, from him down, if he looks at milepost A, it was a 33-degree angle. If he looks at milepost B, it was a 50-degree angle. And he also, we know the difference between the 2 mileposts ends up being 4.7 kilometers. So it says find the distance of the plane from point A. So the plane is right here. Here's my plane. So I want to know what the distance is from point A. So in other words, we're looking for our little A here. So it might seem like we don't have enough pieces, but it says straight highway on purpose to let you know that this blue line here is also a straight line. Straight lines add up to 180 degrees, right? Think about your axis here. This is 180 degrees, straight line. So if we know we have 33 degrees and a 50 degrees, that would add up to what, 83? So if I subtract that, that tells me that this piece here must be 97 degrees, so that they add up to 180. So now I have a pair here that I can use. We also have, let's see, parallel lines here. So I forgot what the symbol for parallel lines is. Do you kind of do that? So these are also parallel lines. So we can find another piece simply by, and which piece do we want? I guess we're trying to find this one. So we would want this angle over here. So we have 2 lines being cut by a transversal like this. And what we'd like to do is try to figure out what this angle is. So remember, he would be the same as this one, right? Alternate interior angles are congruent. So sometimes I just have to take it off the picture because there's too much going on in the picture. But this and this would actually be the same. So if that's 50 degrees, we know that this one is 50 degrees because they are alternate interior angles. So now we can set up our law of sines ratio, and we'll have that the sine of 50 degrees is to x as the sine of 97 degrees is to 4.7. And then this is all in kilometers. So then we can figure out that x is approximately 4.7 times the sine of 50 divided by the sine of 97 degrees. So that's going to give us x, and keep in mind that is in kilometers. So if this were on your own paper, don't forget to label that. And then it also wants the elevation of the plane. So that is actually going to be the height straight down like this. And that is a 90-degree angle. So things might come out a little nicer there, right? With your opposite hypotenuse kind of stuff going on. So, and actually, I guess I'd look, you just found X. So might look this way instead. So this is 33 degrees. That's 90. you know X and you're trying to find this one. So you could use opposite of hypotenuse, right? So you could use sine of 33. So that's opposite and over hypotenuse. So then you can solve that for H. Sorry, I guess I shouldn't have used H, but I meant for that H to be height. So kind of a neat question there. And using like some old school geometry to see that angle. You may actually have to do that on that last question too, use some geometry. All right, so some word problems with law of sines and some others. And that is our law of sines.